So remember, in the first video, what we did was we took the net force and we used that to find the acceleration, and then the acceleration to find the kinematics. It's quite a bit easier when we go the other way, when you're given the kinematics variables and you solve for A and then find the net force acting on the object. So I have a truck that is an 11,500 kilogram truck, which means that's going to be the mass of our truck. Applies its brakes, which means I'm thinking I'm going to have a negative acceleration, and changes its velocity from 35 meters per second, that's got to be my initial velocity, to 10 meters per second, which is my final velocity, in 5 seconds, which will be my time. So looking at those, it looks like I have three variables out of my kinematic equation. So what I'm going to do is look for the equation that has VF, VI, A, and T in it, and that's going to be the second one that we looked at, the not squared one. So I'm going to say VF equals VI plus AT. I have a final velocity of 10. I have an initial velocity of 35, and I'm looking for A, and I have a time of 5 seconds. So if I subtract that over, I'm going to have a negative 25 equals 5A. Divide both sides by that, and I'm going to get a negative 5 meters per second squared. So again, it comes out negative because it is slowing down. And then once I have that acceleration, I can take and apply that to an F equals ma, saying, hey, there's got to be a force that's causing that acceleration. We're given the mass, it's that 11,500 kilogram times the acceleration, which we just found to be the negative 5. And so that force, whenever you multiply those out, comes out to be negative 57,500 newtons. Again, it's negative because the force is acting against the object, and so it's pushing it, slowing the truck down. And then it's a very large one because it's a very large mass and it's being decelerated. So again, that's the second way that you can do these really, really basic ones. In other videos, we're going to talk about when the forces are equal and we have everything cancels out, and or we're going to add friction into these and make them slightly harder, and then even go one step further to say, hey, what happens if we have different objects interacting with each other? But for now, that's a good beginning for dynamics.